This is Mr. Beck Does Your Homework. This is AP Physics, Homework 2.7, question number 7. It says a 0.67 kilogram rock is projected from the edge of the top of a building with an initial velocity of 11.6 meters per second at an angle of 52 degrees above the horizontal, as shown. Due to gravity, the rock strikes the ground at a horizontal distance of 19.5 meters from the base of the building. How tall is the building? Assume the ground is level and that the side of the building is vertical. The acceleration of gravity is 9.8 meters per second squared. So let's see what we know here. I've got an x world and I've got a y world. What do I know in the x world? I know my acceleration is 0 because it always is in the x world. In my y world, my acceleration is gravity is negative 9.8 meters per second squared. In the x world, I know that when this rock goes and lands on the ground, it's 19.5 meters away. So I know my displacement in the x world is going to be 19.5 meters. My y world height is what I'm really looking for, that displacement, because this rock is going to go up and come back down, and by the time it goes down, it's going to have a vertical displacement of that height. So I'm looking really for my y displacement, and that should give me a negative, but I know buildings are tall and not negatively tall. The other thing I know is that this 11.6 angle of 52, well, I've got 11.6 at an angle of 52, and that is made up of a y component and an x component. So this is my initial velocity in the x world and my initial velocity in the y world. And so if this is v, then velocity in the y world is going to be, since this is theta, this is my opposite of theta, and I know from SOHCAHTOA sine has to do with the opposite, so vy is going to be v sine theta. So my initial velocity is going to be v sine theta. In the x world, my velocity is just one velocity since there's no acceleration, so this is going to be vx, and vx has to do with the cosine because it's adjacent to that angle, so cosine, SOHCAHTOA, that winds up to my velocity in the x world is going to be that initial velocity times the cosine of theta. So this v is going to be 11.6 times the cosine of 52. This v is going to be 11.6 times the sine of 56. So the sine of 52. Now I am looking for how tall is the building. I have an acceleration. I don't know my displacement. I don't know my time, but I do have an initial velocity, and I also don't know my final velocity. So I'm short a variable somewhere. Luckily, since I know it lands 19.5 meters, I can figure out my time from my x world, because in the x world, since my distance is going to be my velocity times my time, I don't have to worry about a 1/2 at squared here because it's no acceleration. I know that my time is going to be my distance divided by my velocity. So the time here is going to be my distance of 19.5 meters divided by my velocity, which is 11.6 cosine 52. That'll give me some amount of time that will be good for the whole problem. So if that's the time here, then that's also the time here. Now, acceleration, initial velocity, time, and I'm looking for displacement. So now I can do that my displacement is my initial velocity times time plus 1/2 my acceleration times time squared. So now my y that I'm looking for is going to be my initial velocity. So that's going to be v sine theta, right, which I've also already solved for here, times time plus 1/2 gt squared. So this is going to be 11.6 sine 52 times my time that I got from here, plus 1/2 of negative 9.8 times the same time squared. So this is a little bit of math, but that will give you your height. That should give you a negative number, but since you're looking for the height of the building, really make that positive. So whatever you get there, absolute value it, and that's going to be the height of the building. The height is going to be the absolute value of your y.